Good morning. This is R. Premananda. Subject Signals and Systems, Model 1, Session 3. Myself, Assistant Professor, Government Engineering College, Haveri. In this session, we are going to discuss about the signals classification. The signals are classified as continuous time signals, discrete time signals, deterministic and non-deterministic signals, even and odd signals, periodic and aperiodic signals, energy and power signals, and real and imaginary signals. In this session 3, abstract level of the discussion will be done. In and detailed discussion we will going to discuss on every topic of the signal system in from of next coming sessions. Okay. However, a continuous time signal. A signal is said to be continuous time when it is defined for all instants of time. See, it is continuous in nature. And deterministic or discrete time signal. A signal is said to be discrete when it is defined at only discrete instants of time as shown in figure. Okay, it is here the discrete time signals we call it the sequence. Rather than signal, we prefer to call it as a sequence. Our signals, continuous time signal is going to call as signals. Deterministic and random signal. A signal is said to be deterministic if there is no uncertainty with respect to its value at any instant of time. No uncertainty. Okay. Or signals which can be defined exactly by mathematical formula are known as deterministic signals. There is no certainty, uncertainty will be there. Means it's a formula. If it has been given this way, means it has to be that way. Sinusoidal signal, exponential signal, everything mathematical. No random in nature. It is called as a deterministic signal. What is non-deterministic? Non-deterministic is nothing but it's a random signal. A signal is said to be a random or non-deterministic if there is uncertainty with respect to its value at some instant of time. Non-deterministic signals are random in nature and hence they are also called as random signals. Random signals cannot be described by any mathematical equations. They are modeled in probabilistic terms. See, no mathematical equation can derive what this signal is, how it is. It's a random in nature. Okay. Even and odd signal. A signal is said to be even when it satisfies the condition x of t is equal to x of minus t. Then we call that signal is an even signal. A signal is said to be odd when it satisfies the condition x of t is equal to minus of x of minus t. We'll have an example. Here t square, t to the power of 4, cos t, etc. are all belongs to even signal. How we will discuss here with a simple example. X of t is equal to t square and x of minus t is equal to minus t whole square, that is nothing but t square itself. So that t square is an even function. See another example, it has been given with a rectangular signal by seeing the diagram. This is the x of t. X of minus t means folding or reversing the signal or folding the signal. And so, by doing same thing or folding, the signal will unchange in its shape. Means is that it is a symmetric signal. Every symmetric signal is also an even signal. Okay. A signal is said to be odd when it needs to satisfy the condition x of t is equal to minus into x of minus t. So t minus t cube and sin t, these all belongs to the odd signal. Let x of t is equal to sin of t. We replace t by minus t, so x of minus t is equal to sin of minus t. See, sin of minus theta is equal to minus sin theta. The trigonometric function, we know that. So that minus sin t. So that minus sin t, you can write this as sin t is nothing but x of t. So that x of minus t is equal to minus of x of t. It is called as an odd function. So sin t is a odd function. Any function f of t can be expressed as the sum of its even function f of t and odd function f naught of t. So the total f of t is a complete signal, and we have f of t the even part of the f of t, f naught of t is the odd part of the f of t, where f of t is equal to 1 by 2 times the f of t plus f of minus t, and f naught of t is equal to 1 by 2 times the f of t minus f of minus t. periodic signals and aperiodic signal. A signal is said to be periodic if it satisfies the condition x of t is equal to x of t plus capital T, where capital T is the period. For discrete time, it is x of n is equal to x of n plus capital N, where n is the period. Where t is the fundamental time period, capital T is the fundamental time period, f is equal to 1 by t is the fundamental frequency. T naught is the one period signal, is the interval of the one period signal. In the given diagram, the above signal will repeat for every in time interval t naught. The above signal will repeat for every time interval t naught, hence it is periodic with the time period t naught. Energy and power signal. A signal is said to be energy signal when it has a finite energy. Energy equation is given by E is equal to some integration of minus infinite to plus infinite x square of t. If this value is finite, then we call it as the energy signal. If the power equation is finite, then we call that as the power signal. Okay, we have got the two equation, energy and the power. If we got the finite value for the energy equation, it's an energy signal. Finite value for the power, then it is called a power signal. A signal cannot be both simultaneously. A signal cannot be both simultaneously. Energy and power cannot be both energy and power signal simultaneously. Also, a signal may be neither energy nor power signal. The power of energy signal is 0. The energy of power signal is infinite. Okay. Real and imaginary signals. A signal is said to be real when it satisfies the condition x of t is equal to x conjugate of t. A signal is said to be imaginary when it satisfies the condition x of t is equal to minus x conjugate of t. If x of t is equal to 3, then x conjugate of t is equal to 3. If x of t is equal to 3j, then x conjugate of 3 is equal to 3 minus 3j. For real signal, imaginary part should be 0. Similarly, for an imaginary signal, the real part should be 0. Now, previously we discussed about the types of the signals. Now we go to discuss about the operation on dependent and independent variable. What is dependent variable? Here amplitude is a dependent variable, whereas time is an independent variable. Time doesn't depend upon any of the parameters. There are two variable parameters in general, amplitude and time. See, now we will first go and discuss the following operation performed on amplitude, that is dependent variable. Firstly, scaling, amplitude scaling. You have been given the x of t. C is the amplitude product. Okay, x of t is amplitude. C into x of t is an amplitude scaled version of x of t, whose amplitude is scaled by a factor of capital C. See the first diagram, x of t. Now it's 2 into x of t. The scaling factor is 2. Means that the earlier x of t is multiplied by the amplitude of x of t is multiplied by 2 to achieve the new signal as shown in the figure B. That is 4, the amplitude is 4. 0.5 into x of t. See the here the scaling factor is 0.5. So 2 into 0.5, the amplitude which has been earlier it was 2, now it is scaled or reduced to amplitude of 1 as shown in the third diagram. Now addition of the two signals. Here we have considered the two signals. Addition of two signals is nothing but the addition of their corresponding amplitudes. This is the best way can be explained by using the example. See, first x1 of t have been taken which is having the values of amplitude 1 or between the minus 3 and plus 3, elsewhere it is 0. Similarly, another signal x2 of t which is going to have the amplitude of 2 for a range of minus 10 to plus 10 and 0 for the elsewhere. So if you add these two signals, we get for the duration of up to minus 10, above plus 10 we have got the 0 because both the signals have the amplitude 0. For that period the amplitude here is 0. For duration between minus 10 to minus 3, we got the x2 of t as a amplitude 2, and whereas the x1 of t is 0. So that for duration of minus 10 to minus 3, they will have the amplitude of 2. The same thing is in this side, plus 3 to plus 10. For the duration of minus 3 to plus 3, if we got the x1 of t as 1, whereas x2 of t is 2. So that the amplitude is 3. This duration you got 3. That is shown here. The conceptually it has been explained. x1 of t plus x2 of t, for this duration 1, and the we got x2 of t is 2, so we are going to get the x3 of the new z of t is equal to 3. Subtraction, similarly, the same example which have been taken. See that for minus 10 to minus 3, x1 of t minus x2 of t, x1 of t is 0, x2 of t minus 2, so you get the period minus 2 amplitude. For duration minus 3 to plus 3, x1 of t is plus 1 and x2 of t is minus 1 minus 2, so 1 minus 2 is equal to minus 1. For this duration you are going to have the minus 1, and for time period greater than 3 and less than 10, we are going to get z of t is equal to x1 of t plus x2 of t, 0 minus 2 we are going to get minus 2. Elsewhere this will be 0. Multiplication, same ways, okay, same thing. See both, we have, see that multiplication up to minus 3, this is for x1 of t is 0, so 0 multiplied by anything will be 0. After plus 3, again x1 of t is 0, so 0 multiplied by anything is equal to 0. So from minus infinite to minus 3 is 0, plus 3 to plus infinite, this is 0. For the duration between minus 3 to plus 3, x1 of t is with amplitude 1 and x2 of 3 is with amplitude 2. So 1 into 2, this becomes the amplitude 2. The time shifting. Now we are going to discuss the operation on independent variable time shifting. See x of t is equal to x of t plus or minus t naught is the time shifted version of the signal x of t. See, if x of t plus t naught is the negative shift, okay, it means shift towards the negative side. X of t minus t naught is a positive shift. As shown here, this is x of t minus t naught, it is positive shift, t plus t naught, it is a negative shift. Okay, diagram is it has to be reversed. Okay. Time scaling. X of a t, the scaled version of x of t, where a is always positive. Okay, a greater than 1 is called the compression of the signal, a less than 1 is the expansion of the signal. See, this a should be always positive. Okay, see x of t. X of 2t means 2 is greater than 1, the signal will be compressed, and this is x of t by 2 means 1 by 2 is less than 1, so it is a expand. See, 2 means compression by a factor of 2. If it is minus 2 divided by 2, it is minus 1, plus 2 divided by 2 is the plus 1. Okay, whatever this coefficient divided by here, this will go into the compressed version. That is one of the easiest method to do. X of t by 2. Okay, similarly, if minus 2 divided by 1 by 2, it becomes minus 4, plus 2 divided by 1 by 2, it becomes plus 4. Okay, means how to obtain the compressed expansion signal with an easy trick I have explained. See, when the amplitude by factor n, the coefficient of t is greater than 1, it is a compressed version. The coefficient of t is less than 1, it is an expanded version. Okay, this is the time reversal signal. Okay, x of minus t, the time reversal of the signal x of t. If this is x of t, okay, this now x of minus t is shown in exactly the mirror image of the x of t with respect to reference line. Okay. Okay, now the system classifications. Earlier we discussed the signals classification. Now we are going to discuss about the systems classification. Linear, non-linear systems, time variant, time invariant systems, linear time invariant, linear time invariant systems, static and dynamic systems, casual and non-casual systems, invertible and non-invertible systems, stable and unstable systems. We have so many classifications with respect to the systems. A system is said to be linear when it satisfies superposition and homogeneity principles. Consider two systems with inputs x1 of t and x2 of t and output y1 of t and y2 of t respectively. Then according to the superposition and homogeneity, the t of a1 into x1 of t plus a2 into x2 of t is equal to a1 times the x of t of x1 of t plus a2 times the t of x2 of t. Therefore, we can call this t of a1 into x1 of t plus a2 into x2 of t is equal to a1 y1 of t plus a2 y2 of t. From above, the above expression is clear that the response of overall system is equal to the response of the individual system. Linearity tells that the response of the overall system is equal to the response of the individual system. We will discuss this with one example. x1 of t is equal to x square of t. See, y1 of t, t is called the operator. T is an operator and x1 of t is the input applied, so that it becomes x1 square of t. Similarly, y2 of t is equal to applying to that operator, so it becomes x2 square of t. So t into a1 x1 of t plus a2 x2 of t will apply that a into x1 of t plus a into x2 of t square becomes the applying square which is not equal to a1 into y1 of t plus a2 into y1 y2 of t, hence the system is non-linear. Time invariant and time invariant system. A system is said to be time variant if its input and output characteristics vary with the time. Otherwise, the system is considered as time invariant. If it varies, if the system's input and output vary with respect to time, then it is called a time variant. If it does not vary with respect to time, it is called as a time invariant. The condition for time invariant is y of n of t is equal to y of n minus t. Y of n of t is equal to y of n minus t, and for the time variant, y of n comma t is equal to not equal to y of n minus t, where y of n comma t is equal to t of x of n minus t. T is the operator, x of n is the input signal, minus t is the shifted signal. Time dependent, time, that is input change. X of n minus t is the input change, y of n minus t is the output change. For example, we will have an example. Y of n is equal to x of minus n. Okay. Y of n comma t will apply that t into x of n minus t. Okay. Here x of n is x of minus n. There we are applying that minus t. And similarly, now y of n minus t, replace n by n minus t. Okay. Replace n by n minus t, so that first equation becomes y of n minus t is equal to minus common n minus t. So it becomes that yx of minus n plus t. So both are not equal. Means that y of n comma t is x of minus n minus t, whereas y of n minus t is equal to x of minus n plus t. Both are not equal. Hence the system is time invariant. Means it changes with respect to time. Linear time invariant and variant and linear time invariant. If a system is both linear and time variant, and it is called the linear time variant system or LTV system. A system is both linear and time invariant, then the system is called as linear time invariant system, LTI system. Static and dynamic systems. A static system is a memoryless system which does not have any memory, whereas a dynamic system is a memory system. So we'll study that example. Memoryless means it doesn't depend upon the previous value. The memory means it depends upon the previous value. We'll have an example. Y of t is equal to 2 times the x of t. For present value t is equal to 0, the system output y of 0 is equal to 2 into x of 0. Here the output is only dependent upon present input. Hence the system is a memoryless or static system. A system is said to be memoryless when its output depends upon only the present input. We call it as a memoryless system. We have another example. Y of t is equal to 2 into x of t plus 3 into x of t minus 3. Suppose for present value t is equal to 0, y of 0 is equal to 2 into x of 0 plus 3 into x of minus 3. See that the second parameter, that minus 3, means that if for this example the present output depends upon the past input also. Means it requires memory. In order to remember the past input, it requires the memory. Hence this system is called the memory system. That is, If the signal present output depend upon the past input, then it is called as a memory system. Okay. A memory system are nothing but dynamic system. Memoryless system is nothing but a static system. Causal and non-causal system. A system is said to be causal if its output depends upon present and past inputs. Okay, it is causal when it depends upon the present and the past inputs and does not depend upon the future inputs. If it depends upon the future input, we call it as a non-causal system. Okay, if it does not depend upon the future output, we call it as a causal system. We'll have that. For now, we will one example. Y of n is equal to 2 into x of t plus take that as y of t. Y of t is equal to 2 into x of t plus 3 into x of t minus 3. For present value t is equal to 1. The system output is y of 1 is equal to 2 into x of 1 and 3 into x of minus 3. See, 1 is the present status and minus 2 is the past. So for this equation we require the present and the past, not the future. So the given example also is for the causal system. It is for the causal system. Okay. If the system we introduce this equation, whatever that system we call it as the causal system. We'll have another example. Y of t is equal to 2 into x of t plus 3 into x of t minus 3 plus 6 into x of t plus 3. Now we'll mean that t is equal to 1. When present, I want to know the present t is equal to 1 time 1 this period. So y of 1 is equal to 2 into x of 1 plus 3 into x of minus 2 plus 6 into x of 4. So present situation is t1, whereas first two term x of 1 is x of 1 means it indicates the present input, x of minus 2 indicates the past input, whereas x of 4 means the future input. See, this system not only depends on the present and the past, but also depends on the future. So this is called as a non-causal system. The invertible, non-invertible systems. A system is said to be invertible if the input of the system appears at the output. If the same input of the system is appeared at the output of the system, then the system is called as invertible system. So here for h2 of t, see, this is y of the response. Okay, y of s is the output, x of s is the input, h1 of s is the first response, h2 of s is the second response. Here we will introduce h2 of s equal to 1 upon h1 of s, so that y of s is equal to h of s. So y of t, taking the inverse of that, we get y of t is equal to x of t. The above system is called the invertible system. If y of t is not equal to x of t, then the system is non-invertible system. Stable and unstable system. The system is said to be stable only when the output is bounded for bounded input. For bounded input, if the output is unbounded in the system, then it is said to be unstable. Note, for bounded signal, the amplitude is finite. So y of t is equal to x2 of t. Here let the input is u of t. x2 of t is equal to u of t. Unit step bounded input. Then the y of t is equal to u of t, the bounded output. Y of t is equal to x2 of t, the bounded output. For bounded input, for bounded output. Here y of t is equal to integration of x of t. So here I will put that u of t, the step bounded input, then the output y of t, the integration of u of t with respect to dt is equal to ramp signal. Ramp means for t is equal to 0, the output is 0. For t is equal to infinite, the output is infinite. Means for bounded input, the output is not bounded. So it is called as a unstable systems. Okay, if you got the for bounded input, if you get the bounded output, then we call the system stable. For a bounded input, if you got the unbounded output, then it is called as an unstable system.